And welcome everybody to the Daily Space Weather. I'm your host Dan, aka smAsho. We finally see sunspots north of the solar equator, otherwise known as at north solar latitudes. Large earthquake strikes at the Philippines, and more. We'll talk all about all the data. So first of all, we're looking at a 94 angstroms view of the sun here. You can see sunspot 2797 right there. Sunspot 2798 forming right there at the end of the video, and an active region rising in the northeast as well. Most likely a sunspot. It's got very large plasma filaments associated with it being suspended by that magnetic field. Here's the same view from the SDO in 304 angstroms. The 10.7 centimeter radial flux now at 78. There's the 1-year chart from Solon.info to put that into context. And for you new viewers, thanks for tuning in. The 10.7 centimeter radial flux, a measurement of the solar outer coronal radio output, the output of the sun's outer atmosphere. Very proportional to sunspot number. Let's take a look at what's going on at Lagrange point 5 as we saw some coronal mass ejections. Here's the view from stereo A. And those do not appear to be Earth-facing coronal mass ejections. We'll show you a quick view here from Lagrange point 1, part of the Discover spacecraft. It's the LASCO C3. And you can see Jupiter and Saturn in that image as well there on the left, those two bright points. And keep in mind, this one's a little bit deceptive, as there are really two coronal mass ejections that have happened at the same time here, one of them opposite of the Earth-facing side. You can see sort of the tail end of them here. We're expecting the one that's on this. The Earth would be out in this direction from Lagrange point 5, and we would expect that portion of the coronal mass ejection to miss the Earth to the west. So here's a chart of the planets at theplanetstoday.com. There's where things will be in a week. I think that would be full moon day on the 29th. And we've got some great HelioViewer movies as always. Let's bring this one up real quick. This is the active rising region. Great view of that. Put that on loop. So finally, some activity in the northern hemisphere, as we've seen the only sunspots for quite a long time showing up south of the solar equator. Here's another view of the full disk. This is the past 24 hours and 193 angstroms. Earth-facing coronal hole there ahead of sunspot 2797. And at the end of the video, once again, you'll be able to see sunspot 2798 forming in the northwest. We've got close-ups of it. Here it is in magnetogram. You see it forming right around this area here. I'll let that play through a second time for you. And here's that same area in 171 angstroms. Seeing what the ionized iron is doing as that sunspot forms. 171 angstroms, a crowd favorite. Here's the southern hemisphere in 193 angstroms. South Pole coronal hole, as well as the South Polar coronal hole. And a good view of sunspot 2797 as well. We've got some more close-ups. We're going to save some of them for the end and show some of them right now. Here's a close-up of sunspot 2797 in that same wavelength. Great view of that coronal hole as well there. Allow me to vanish. And here's a close-up of sunspot 2797 in magnetogram. You can say it's been pretty stable here over the past 24. And let's move on to some more data. Now, if you haven't checked out our lists, our playlists, that is, check out youtube.com/smashomash/playlists. We've got a bunch of them, among them the Smash Lights segment. Today's Smash Lights segment will have to be postponed until later, perhaps. We're going to look at some more data, such as which volcanoes have been erupting. I'm always interested. Klyuchevskoy is on the list. It's producing a 22,000-foot altitude ash plume. Suwanosejima, flight level 070, as it's got a 7,000-foot ash plume above its caldera. It would not be wrong to say Raung is exploding and producing a 13,000-foot ash plume on East Java. Semeru, located nearby, flight level 120, 12,000-foot ash plume there. Popocatépetl exploding down in central Mexico, 20,000-foot ash plume. Fuego exploding, 14,000-foot ash plume. Sangay exploding, 22,000-foot ash plume. Revenador exploding, 14,000-foot ash plume. And Sabancaya exploding and producing a 26,000-foot plume of ash. Please don't pole vault the caldera. And man, oh man, how much carbon dioxide, methane, sulfur dioxide, carbonyl sulfide, and other global cooling chemicals are all of those volcanoes adding to the atmosphere? It's a pressing question. Largest quake of the past 24 happened yesterday at 12:23 Universal Time. It's a 7.0 south of Davao City. There's the location of that, out in the ocean there. West of the Isle of Palau, in the southern Philippines, in between Philippines and Indonesia. Let's look at all the earthquakes of the past 24. And that was nearly at 100 kilometers depth, folks. Let's hope that's not a precursor to a larger quake. If that one happened at the surface, that would be more like a 7.3. And we'll just scroll up the list here. At least some aftershocks happening after that 7.0. Some deep quakes like this aftershock here. So this aftershock occurred at a deeper depth, but a 4.5 magnitude. Here's a 4.4 at Afghanistan at nearly 200 kilometers depth. A 4.6 at the Philippines, right in that same area. This one a little deeper than the 7 magnitude quake at 101 kilometers. Here's a very deep quake at Fiji, a 4.5 at 563 kilometers. A deep quake at Puerto Rico. Shout out to Peter Schiff. Peter Schiff, please tell your friends and foes, science noobs and science pros, to view the content, as we didn't expect to be the world's leading solar forecaster. We just are. Here's a 4.4 at Chile at depth as well, 116 kilometers. Small deep quake strikes Alaska. Another small deep quake strikes Alaska. And so there you go. There's your earthquakes of the past 24 hours. Let's continue on to look at the real-time solar wind. And by the way, I discovered what was wrong with the real-time solar wind. My Brave browser, I had to turn off the ad blocker. I turned off the shield, and now the real-time solar wind works great. If you're having problems with it, perhaps turning off your ad blocker will help you as well. So we see the phi angle has recently shifted over the past 6 hours. Solar wind density currently around. All right, I don't know what it's around. Let's press refresh and see what happens. Again, we are streaming live, folks. It's twitch.tv/smAsho. Maybe that's not the solution. Let's see if I can get the 3-day data. And it's just not cooperating here. Solar wind density just over 10 protons per cubic centimeter. Solar wind speed just over 300 kilometers per second. So a weak solar wind speed there. The KP index at 0 over the past 6 hours. And that's a measurement of global geomagnetism if you weren't aware. Here's 4 hours of geospace magnetosphere movies. We're hoping. And you can see pretty weak magnetohydrodynamic pressure there. by that slow and not particularly dense solar wind stream. Here is the ground magnetic perturbations. We're looking at changes in the Earth's B field here. Nothing too exciting happening there. This data courtesy University of Michigan. And we show it daily since we're living through a polar excursion. Let's talk cosmology, as here at the Smash News Network, we regularly talk cosmology in that various aspects of astronomy, cosmology, geophysics are constantly being rewritten. And so we cover things and we try to be on the cutting edge. Cosmology is one of those things. So let's get into it. Today I rolled a die, a 1031-sided quantum die, and today's number is 982, which coincides with, on the Neil Gorell Swift-Bat X-ray Observatory, lenticular galaxy NGC 7213, located at about 72 million light-years. This lenticular galaxy is somewhere in between a Seyfert active galactic nuclei and a liner, which is a low ionization nuclear emission line region. Without getting too in-depth into that, it's just a lenticular galaxy. Here it is on Aladdin Light. We'll show it to you in a couple extra wavelengths here. Here it is in infrared on the 2-mass. And infrared is a great wavelength to view distant objects. And here it is on the XMM Newton, the multi-mirror X-ray observatory. And we'll show it to you on Sinbad as well. There it is on Sinbad. Galaxy NGC 7213. There are the X-ray outputs. And the bottom left is the 30-day X-ray emissions from NGC 7213. And you can see this one's been covered historically dating back about 15 years. And it's a pretty consistent X-ray source. And that's today's cosmology segment. We wanted to keep it short. And if you want to follow transients yourself, these are soft X-rays. You can follow them yourself. I'm sorry, they're hard X-rays at the Neil Gorell Swift X-ray Observatory. Also, I would invite all of our viewers to check out our own websites and our social media links, smashomash.com. You can find our stores there. And we've opened a new one, which is linked below the video, to the Google-defined classic t-shirt. And there are about 50 different products here. It comes in all kinds of different colors. For example, how about in red? Or how about in blaze orange? Yes, because nothing says don't run me over or shoot me like a blaze orange shirt. And this is the new design because the term Google has been incorrectly defined as using the Google search engine to obtain information about something or someone on the World Wide Web. We've added the word biased. And here's how to use it in a sentence. I Googled it, and now I know less about it. It's enough to make you want to vanish off of the internet and hold those accountable. And welcome to year 2021, the year of accountability. By the way, we are streaming live to Twitch. It's twitch.tv/smashomash. Thanks to our followers over there. Perhaps consider downloading the mobile app if you're viewing someplace else. If you haven't viewed our playlists on YouTube, check it out. We've got the Smash Lights segment. We just made a new one this morning for product reviews because I needed to do a review of the very mic I'm talking into now. Also, nature videos, daily space weather, cosmology segments. That is a blank and that is a hole in the ground. The Diamond Anvil Too Hard to Smash. Paranormal Smash Files, etc. And please press like and subscribe if you enjoy this content. Don't forget to press share. Tell your friends, foes, science noobs, and science pros. Share on your social media. Get involved. Leave a comment. And thanks to our new subscribers over at YouTube. Thanks to all our new subscribers over at BitChute as well. You'll find exclusive content there, bitchute.com/smashomash. We saw the writing on the wall long ago and decided to expand into alt tech. Next, thanks to our patrons, the true source of funding for the content. Please consider becoming a patron and funding our operation at patreon.com/smashomash. Thanks once again to our patrons, our latest patron. Thanks for becoming part of the Smash team, and expect to see yourself on the credit crawl list early in February. And that's the cosmology segment. Let's get back to current data. And once again, we're seeing a flare happen while I make the video. So here we've already made it into B-class flare range. Interesting to see if that will be a bigger or if that is already peaked out. And largest flare of the past 3 days was this C-class. We covered it yesterday. We don't see any proton strikes. No coronal mass ejections currently striking the Earth environment. And let me just take a moment to check the life of the stream here before I move on to the magnetic information. There's the 3-day chart of the GOES magnetometer. Pretty smooth here over the past day and a half. Spiky going back 3 days ago. Next, looking at the current sheet polarity, as if you're looking at the sun from down on the North Pole, with the polarity of the current sheet between the sun and Earth shown in red and green. South Pole and North Pole polarity respectively. This data is 1 hour and 57 minutes old, and you can see the Earth solidly in the South Pole current sheet shown there in red. There's the latest image. I would expect us to still be in the South Pole current sheet when we make tomorrow's daily space weather video. Here's a line of sight coronal hole plot, which also shows you the South Pole oriented coronal hole. Small North Pole coronal holes around the equator as well. No major changes in the B field, shown there in blue. And lastly, we'll look at the solar coronal magnetic field plot. The magnetic field plot of the sun's atmosphere. It'll show you open potential field force lines in either black or purple, depending on if they're polar coronal holes or non-polar coronal holes. And it'll show you closed potential field surface source lines in pink. Not a lot to comment on there. It's a chaotic place. Next, we're looking at the Earth's ionosphere. And this is a full day worth of data, courtesy Government of Australia Bureau of Meteorology. Ionosphere looking pretty normal here. Here's the latest image coming in at 9:45 Universal Time. Nothing to write home about there. Next, we'll talk electrons. And there's the relativistic electron forecast. I think I actually nailed this one. Correct me if I'm wrong. Yesterday, I think I forecasted exactly where it is. And the yellow diamonds there are the observation. The green squares are the forecast. No arguments about the upcoming forecast. Here's the total electron content forecast. This is basically showing you the electron content of the inner Van Allen belt from a distance of about 12,500 miles, where your GPS satellite will be located, down to ground level. And we do see some anomalies here once again over North America as well as over Antarctica. And we typically see more electronic anomalies happening when electron flux is at low levels, as the electron belts seem more organized at higher levels of electron flux. Here's a 3-day chart of that, and you can see quite low levels there of the past 3 days, and that's measured by the GOES 16, which measures at the ionosphere layer, the same satellite from which we gather the magnetometer data, the X-ray flux, and the proton flux. Here's a 1-year chart of the electron flux to give you a historical context, and you can see those low levels currently where the Earth is at. Here are the jet streams of the Western world, and they're quite incoherent in the Southern Hemisphere, quite concentrated over the eastern U.S. And we see some pretty extremely weird jet stream flow around the South Atlantic anomaly, which is, by the way, right around here, where you see some oddities happening in the jet stream. Here are the jets of the eastern world, I think. There we go. There are the jet streams of the eastern world. I would note once again the jet stream blowing backward, east to west, over the western Pacific and Indian Oceans. Next, some more meteorological data, looking at pressure cells, major anticyclone high pressure zone over central Greenland, as well as a powerful low over northern Europe once again. We'll just advance this till tomorrow. There's the GFS forecast for pressure at tomorrow at noontime. A triple low centered around Nova Scotia. And high pressure dominating the North Central Pacific. Let's continue on. It's value-added services. It's the GO 16 lightning mapper, and there's not a lot of lightning to map. A little bit over Mississippi. Let's check the real-time lightning maps. I like to use lightningmaps.org. And the lightning is at a pretty calm state right now. Lightningmaps.org, I use it when I hear thunder. Have you tried it? Have you forecasted thunder and freaked out your foes and convinced them that you're Thor? Here's a U.S. Doppler radar map. Some heavy rains here over Louisiana, Alabama, Mississippi, and Georgia. Here's a water vapor map of the entire western region, the Americas. And it looks like some dry air over my head. I'm located in Lehigh Valley, Pennsylvania, which is right under this string of dry, massive air there. And let's take a look at the cloud layer over the lower 48. I'll blow that up. Actually, let me take a look and make sure the life of the stream is good yet. And we are just fine here at the Smash News Network. So there's what's going on the cloud layer. Here's a water vapor map. And we'll rock it back. And we've got bonus features. We'll show you our final images of Sunspot 2797, as well as close-ups of Sunspot 2798, intensitygram, colorized magnetogram. Also, don't forget to press like and subscribe on YouTube. Press the share button, share on your social media. Tell your friends, foes, science noobs, and science pros about the channel. We need your assistance. And thanks again to our new subscribers. Let's get to the solar intensitygram and colorized magnetograms. So first, here's the colorized magnetogram. There's Sunspot 2798, which is beta class. You can see a leading North Pole umbra and a trailing South Pole umbra there, making it slightly more likely to produce things like solar flares. Here's Sunspot 2797, which is mainly made up of South Pole umbrae. That's South Pole. Those are North Pole. And it's been stable here over the past 24. Here's the intensitygram. There's Sunspot 2797. It has actually degraded a little bit since yesterday. You can see those umbrae are not as clear, and actually the leading umbra has actually split into two separate areas now, having been separated by a light bridge over the past couple of days. And there's Sunspot 2798. It's pretty defined, and there's a slightly increased chance of solar flares as a result of that. And we'll show you the close-ups of Sunspot 2797 to close things out. And there it is in 171 angstroms. Always a crowd favorite. Here's 304 angstroms. Ionized helium. And I think we've also got 131 angstroms. And there you have that, the aqua blue color spectrum of 131 angstroms. By the way, it's not really aqua blue. We artificially colorize the images as it is such a narrow band of the electromagnetic spectrum. Anyway, thanks for tuning in to the Daily Space Weather. Remember, stare at the sun, attempt to understand the physics. And no matter how much the government drives you to drink, if you do drink, don't drive. And since it'll never be now again, welcome to the Neo-Renaissance. Visit our links, and may that solar wind be at your back.